Alright, this is section 3.2. And so what we're doing is we're looking at lines now. Remember, a line is simply y equals mx plus b. Okay, and your x is the x coordinate, y is obviously the y coordinate. The m is your slope, the rate at which something is increasing or decreasing. And your b is where it crosses the y axis. It's called the y-intercept. M is just a number, B is just a number. X and Y are letters, and they stay that way until you specifically define them as individual numbers. And so, typically a line is of some form such that when you plug in an X, you get a specific Y. You plug in another X, you get another specific Y. So X is known as the independent variable because it can be anything. And then based on that independent variable, you've got a dependent variable, which is known as your Y coordinate. And so, y equals mx plus b. Alright, so you got y equals x plus 3, and they ask you, is 1, 4 a solution? Well, the only way you can know that is to plug 1 in for x and 4 in for y and see if you get a true statement. So you plug 1 in for x, 4 in for y, and you get 4 equals 4, which is a true statement, so yes, it is a solution. And the same thing for this one. This is a different line and a different point. And so you plug in 1/2 for x and negative 4 for y, and you multiply it out, and you get 5 equals 5. That is a true statement, so you can say, yes, that is a solution. Alright, and then for part C, you got negative 5 and 1, so you plug those in, multiply it out, and you get 25 equals 20, which is not true, so no, it is not a solution. Alright, now example 2, it says complete the table for y equals 2x minus 3. So you take your calculator and you hit y equals, okay, and you type in 2x subtract 3. So 2, and your x key is found right here. It's the second row, second one over. It actually says x, tau, theta, and n. So, but that's your x key. So x, and then you subtract and 3. Now remember, you hit subtraction here. Your negative key is right here. Okay. Your negative key is on the bottom, and you don't want to use that unless you're changing a number from a positive number to a negative number, but otherwise subtraction is what you want to use here. Okay, so now you hit 2x subtract 3. Now how do you look at a table for this? Well, you have to do two things. You have to ask to set up your table, which is called table set, and notice on your calculator you have all these blue buttons here, the blue things that are above each number. And you also have the green things that are above each number. Now if you want the blue or the green above each number, you got to hit the blue or the green key before you hit that key. So if I want table set, I have to hit blue and then this button, and that'll give me table set. So second window gives me table setup. And now you typically want to start out with 0 and go up by increments of 1. So the first number is what your table starts at, and the second number is how far apart your numbers are, and they're usually 1 unit apart. So you want to go 0, 1, and you always want these last two to be auto and auto. Alright, so now once you've typed in 0 and 1 for each of those numbers, then you want to hit second graph. Second graph gives you table. Okay, and it gives you a nice table of values from 0 to 10, and if you want negative numbers for x, you can just arrow up and you get the negative numbers as well. Okay, so this one, they want you to complete the table, and they give you minus 4 to positive 2. So minus 4 is negative 11. Minus 2 is negative 7. 0 is minus 3. And 2 is positive 1. And so you can complete that table using your calculator, or you can complete the table by plugging in these x values into the equation and figuring out what the y value is. That's what I did here. Either way, you can do it either way. Now, example 3 says use y equals these numbers to make a table of solutions for this guy here. Alright? Well, that one's a little more difficult because you can't plug this into your calculator the way it is written. You would have to solve this for y first. You'd have to take 5x plus 2y equals 10, and you have to solve that for y, so you'd have to subtract 5x. So you get 2y equals minus 5x plus 10. And then you'd want to divide everything by 2. And so you get y equals minus 5 over 2 x plus 5. And now you're ready to plug it into your calculator. You can type in, how do you type in negative 5 over 2? Well, you type in, you want to hit clear first. You hit y equals and then clear to get rid of your old line. Type in negative 5 divide 2. Okay, and then after that you want to type in the x and then add 5. Oops, add 5. Okay, and now second table gives me a whole table of values here. And so we want for the values of y equals 0. Y equals 0 is when x equals 2. And y equals 5 is when x equals 0. And y equals 10 is when x equals negative 2. And y equals 15 is when x equals negative 4. Okay, so here they give you the y values. You have to look at the y coordinates and then figure out what the corresponding x coordinate is. And so there you go. And so that's your answer. But you can also do it this way. It's a long way. You can plug in 0 for y and figure out what x is. Plug in 5 for y and figure out what x is. And do the same thing for each one. Okay? It's easier if you just solve it for y and then type it into your calculator and let your calculator do the work for you. Right? Example 4 says people with leg injuries often need crutches to an approximate crutch length L in inches for an injured person who is T inches tall is estimated by L equals 0.72 T plus 2. So if you know how tall you are, you can adjust your crutches appropriately the first time around. You don't have to keep adjusting it and trying to figure out what the right number is. Okay, so how do you figure out those numbers there? Use your calculator again. Hit y equals, top left button, hit clear, okay, and now type in 0.72. Instead of t, you're going to type in x, and then add 2. Okay, and now before you hit table, you probably want to hit second window to set up your table, and you probably want to start out at 60, and you want to go up by 5, right, because it's every 5 here. So type in 60 for your starting number and type in your delta table or your triangle TBL. That means how far apart the numbers are going to be is 5. So now hit second graph, which gives you your table. And now you see 60 is 45.2, and they want you to round it to the nearest inch, which is 45. 70 is 48.8, which is really 49. 70 is 52.4, which is 52, and 75 is 56 exactly, and 80 is 59.6 or 60. Okay, so now they say we've completed the table, and so I did it also by hand, typing in the number I want and calculating it out, and I get these same numbers, and I rounded each one. You can also ask yourself, determine the appropriate crutch length for a person that is 5 feet 10 inches tall. Well, 5 feet 10 inches tall is actually 70 inches, not 60. That's not right. It's 70 inches because 5 feet times 12 is 60, plus 10 more is 70. And so 70 inches is 52.4, or roughly 52 inches. Alright. Now if you want to graph something, you just, you got y equals 2x, okay, and you pick some values for x. You typically want to pick 0 and numbers around it. So minus 1, 0, 1, 2, those are fine. And you only need 2 points to graph something, but you generally want to do at least 3 so that you can make sure your point is correct. If you do 3 or more and you find that it doesn't line up like a nice line, like it lines up like a triangle or something, then you know that one of your points is wrong. So it's good to do 3 or more. So you plug in minus 1 in there, times 2 and you get minus 2. 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4. And so you graph the individual points here, and you connect the dots and make sure you put arrows on the ends of each of your points there. Example 6, they want you to graph this, and again, you can just type that into your calculator. Hit y equals, clear, and 1 divide 2, x subtract 1. And then do second table. Well, you notice my table is still set up from the previous time, so I have to do second window to change my setup to 0 and 1. That's a better setup for this question. So second graph gives me my numbers here: 0, -1, 2, 0, and 4, 1. Notice I picked numbers that were multiples of 2 because when you multiply 2 1/2 times a multiple of 2, you get a whole number. Otherwise you get fractions. So 0 times a half is just nothing. -1 is -1. 1/2 times 2 is 1. 1 minus 1 is 0. And then 1/2 times 4 is 2. 2 minus 1 is 1. And you connect your dots and draw your line and put arrows on the end of it. In this one, if you want to graph this on your calculator, you'd have to solve this for y first. You'd have to subtract x from both sides, and you get y equals minus x plus 4. Okay, and then you hit window, or hit y equals, and you hit clear, and negative x, or negative 1x, plus 4. Okay, and now second window, or second graph, gives me my graph here, and I get -2 is 6, 0 is 4, and 2 is 2. Okay, and I get these points, and I connect the dots, draw it, and connect the dots, and all that right there. And so here they show you the same equation with y equals 4 minus x. Well, 4 minus x and negative x plus 4, they mean the same thing. 4 subtract 1x, or negative 1x plus 4. Those both mean the same thing. Now, on your Canvas page, under Files, you'll see a calculator keystroke guide. It's an 8-page guide, and it's real simple, and it has examples that you can work your way through in the problem, and I recommend you do that in order to learn how to use your calculator. Calculator's not too hard, but you want to take the extra time to actually do that and understand how to use your calculator. Alright, example 7. Graph the linear equation 4x minus 3y equals 12. So the first thing we do is we solve it for y, and then we find some points. And again, you can use your calculator. Hit y equals, hit clear, and 4 divide 3, x subtract 4. Second graph gives me my table. And you got 0, -4, you got 3, 0, you got 6, 4. Notice these other numbers have decimals to them. And these are the only ones that are nice whole numbers, because when you multiply something like this times 4/3, unless it's a multiple of 3, you're going to get decimals or fractions. So pick numbers that are deliberately multiples of your denominator, and you'll get nice whole numbers. So you get this here, and you connect the dots, and there you go. Okay, so what did we learn today? We learned about equations in 2 variables. Okay. And we talked about solutions to those variables, and tables of values, which are also solutions to the equations. And a linear equation in 2 variables can be written this way, or you can solve it for y, or you can solve it for x, either one. Right? So these are the problems that are similar to the questions you see on your homework, and they're in the exact same order. So let's look at them one at a time here. First one asks you to check, is this a solution? This is 13 equals 4 times 2 plus 7. So you plug 13 in for y and 2 in for x, and you get a false statement, so it's not a solution. Then you plug in minus 2 for x and 3 for y, and you get a not true statement, so it is not a solution. And then here you plug in 1/2 for y, or 1/2 for x and 2 for y, and you get a true statement, so that is a solution. Okay. Now this one asks you to complete the table, and they give you the x values, and you have to find the y values. Again, just use your calculator, right? Hit y equals and type in y equals 4x, and then hit second table or second graph, and you get all those values for you very quickly. On this one, I used it the old by hand. I didn't use my calculator, but I could have solved this for y and used my calculator. But here they give you the y values, so you want to solve it for x. so that when you plug in the values that you have for y, it's all on one side and it gives you nicely the values for x. So I plugged in each of these y values into this equation and I got my answers. If you don't solve this first for x, you're going to have to do this solving for each one of these problems. It's very important. When they give you a whole bunch of y values, you want to solve it for x. If they give you a whole bunch of x values, you want to solve it for y. Alright? And so, same thing here. They give you x values, 0, 1, 2, 3, and you plug them into this equation and you get your values there very easily. Not too bad. Okay, and then this one they give you y values, so you want to solve this for x, and you plug in these y values and you get the appropriate x values. Okay? Okay, and then this one they want you to make a table of solutions and graph it, and they don't tell you what the x or y values are. Typically you want to solve this for y and then choose x values. So pick 0, 1, 2, 3, those are nice values, right? And so you plug in 0, 1, 2, 3, and 3, and you get these y values and you graph it. And the same thing here. Now this one's already solved for x, so you might want to pick y values and figure out what the appropriate x value is, and you get that. And then this one you want to solve this for, probably you want to solve it for y, so you'd want to subtract x, and you get 2y equals minus x plus 4, and then divide everything by 2, and you get y equals negative 1/2 x plus 2. And now you plug in minus 1 all the way to positive 2 in here for x, you multiply it by minus 1/2 and you add 2 and you get your y coordinate. Okay, y equals x, that's called the identity function. That's just simply whatever x is, y is, because it's a mirror of each other. Each one is equal to the other, so no matter what you pick for x, you get the same thing for y. And so you graph it. It's always a line at a 45-degree angle that goes through the origin. Right? Y equals 4 minus 2x, you pick some nice x values and you get these y values, and there you go. Okay, and this one you pick x values and you get the appropriate y values. You get fractions here, but that's fine. Right? Notice, by the way, if you are to use this idea, okay, if you type in minus 2 into this, right, and check it on your calculator, you can type in negative 1 divide 2 times a negative 2. And you want to put the negative 2 in parentheses because it's a negative number. And then add 1 divide 2. Now notice when you do, you get a decimal. Now if you want to convert that to a fraction, it's very easy. Just hit math, the math key right there, 1, and then enter, and it changed it to a simplified fraction. Your calculator is really nice when it comes to doing things like this. If you want to take something as difficult as 5/11ths, subtract 7/9ths, add 4/13ths. Okay? It gives you some bizarre decimal, and just hit math, 1, enter, and it tells you your answer in lowest denominator in simplified form. So the difficult math you did in 81, where you had to combine these fractions with common denominators first, you had to find the common denominator for each one, and then add them, and then reduce the fraction. All that is gone. You can just do that on your calculator. You just type in each fraction just like you see. It gives you a decimal, and just hit math, 1, enter, and it gives you the simplified fraction for you. So all that is nice and easy now using your calculator. It's a very important thing to remember. Math, 1, enter, changes your answer to a simplified fraction. Alright, so if you want to graph this guy, you subtract 2x, divide by 3, and you get the equation. You plug that into your calculator and get your points. You graph your points, and you got it. In 67, again, you solve it for y. You plug in x values, and notice I picked x values that were multiples of 4, and you get whole number y values, and I graphed it, and there you go. Alright, in 69, we solved it for y, okay, and we picked specific x values, and we got these y coordinates, which are not easy to graph, but there you go. Okay, 9/5 is 9 divided by 5, or 1.8. 3 divided by 5 is 0.6. That's negative 0.6, negative 1.8, and negative 3. Alright, 72 says for the years 2010 to 2050, the projected percentage P of the U.S. population that will be 18 to 24 years old during year T is estimated by this equation. So this tells you, if you input a year, it'll tell you the percentage of the population that is 18 to 24 years old. So they ask you to complete the table for these different values. So you just plug in this into your calculator, and then you want to do table set at 2010, and then the next number is how far apart they are, and you want to say 10 because they're 10 units apart. And then it'll give you numbers that are probably quite complicated, but you want to round it to the nearest tenth or nearest one digit, which means you're going to have to look at the second digit, and if it's 5 or more, this guy goes up by 1. If it's 4 or less, it stays where it is. Alright? So you plug in these numbers and you get 10.1. Plug in these numbers, you get 9.85, which is really 9.9. And this one's 9.6. Don't need to round it. 9.35 is closer to 9.4, and 9.1 is just 9.1. Then part B says one of the population should be 9.4%, so you let P equal 9.4, and you solve it for T. So you subtract the 6035, you divide by negative 0.025, and you get 2038, exactly, I believe. 77. The number of welfare beneficiary B in millions during year T0, year T, is shown in the table. Discuss the linear equation might work to approximate these data. All right. So if you plot your points here, your y coordinates or your b coordinates are between 4 and 12. So I do from 0 to 12 here, and your x coordinates are very large. So I just relabeled this. Instead of normally being 1, 2, 3, 4, 5, I labeled it every 10 years. You can label it however you want. And so 1970 is 7, 1980 is 11, 1990 is 12, and so on. And when you connect the dots here, you can see this is clearly not linear. It's not a line. This is actually what's called a line graph. It's a graph of line segments. Each individual portion of it is a line segment. And so what did we talk about in this section? We talked about y equals mx plus b. We talked about solutions to that. We talked about, is something a solution? It is if it gives you a true statement. Then we talked about using a table, and then finally using a table to graph our lines.